This video I'm going to be introducing similar figures. Now you have heard of similar figures before, probably back in middle school, and most people think about similar figures as being the same shape but a different size. So this year we're going to be building on that idea of similar figures and getting deeper into the meaning of what similarity is. So on the screen, you'll see that we have two triangles, triangle ABC and triangle DEF. And these two triangles are similar. The definition of similar figures is in the box. Two figures are similar if and only if all corresponding angles are congruent and all corresponding sides are proportional. Okay, now that differs from our definition of congruence, because in congruence, all corresponding angles had to be congruent and all corresponding sides had to be congruent. So here we're adding this part about sides being proportional. That means that the sides are not going to be the same. What we mean by proportional is that all of the sides are multiplied by the same number. So take a second and look at the triangle and see if you can figure out what all of those sides are multiplied times to go from the smaller triangle to the bigger triangle. So in these two triangles, we see that ABC is definitely smaller than DEF. If you look at the sides, at the corresponding sides, we have AC corresponds to DF, AB corresponds to DE, and 6 corresponds to 18. So we've got 4 turning into 12, 2 turning into 6, and 6 turning into 18. All of ABC's sides were multiplied by 3 to become triangle DEF. That means that the sides are proportional. They were all multiplied by the same number. Now, we can go backwards too. This isn't just about going from big to small or small to big. We can go both. So look at going backwards. 12 to 4, 6 to 2, 18 to 6. DEF sides were multiplied by what to become triangle ABC? Well, your first thought is that they're divided by 3, but we need to know what they're multiplied by. So if we know something is divided by 3, it's actually multiplied times the fraction 1 over that number, 1 over 3. So triangle DEF sides were multiplied by 1/3 to become triangle ABC. So let's just show you why. 12 over 1 times 1 over 3 equals 12 over 3. Remember, I multiplied top times top, bottom times bottom. 12 divided by 3 is 4. Okay, so they were multiplied times a fraction. We call these numbers scale factors, the scale at which the triangles have changed. That's the scale factor. Now, you may remember this from last year when you talked about dilations. Dilations are the transformations that give us similar figures. This is a dilation. It is a non-rigid motion that changes the size of a figure, okay, but it doesn't change the shape. So here we have a dilation by a scale factor of 3 if we're going from small to big, or a scale factor of 1/3 going from big to small. Now, when we talk about these dilations and similarity, we have similarity statements, just like we had congruence statements. Now, we had the symbol for congruence. Now we have a different symbol for similarity. This is our similarity symbol. It's the squiggle without the equal sign. So we look at our two triangles and we figure out our corresponding sides and our corresponding angles, just like we did with congruent statements, and we make our similarity statement. A is similar to D, or in this case the angles are congruent. B, angle B is congruent to angle E, and angle C is congruent to angle F. Because the sides changed, these two triangles are similar, so it's just the squiggle line. So that's it for this video. Now make sure you go complete the questions and submit them on the Google form, and make sure you hit Mark as Done in Google Classroom.